Hi there, my name is Julio Casal, and in this talk I'm going to give you a quick overview of how to test your .NET REST APIs. I think this is an essential topic for professional .NET developers because of course you want to make sure that you keep the highest possible quality in those REST APIs. And in this talk, I'm going to be covering several topics like unit testing, integration testing, and even this new kind of testing called contract testing, which I think is a great alternative to end-to-end tests. So let's start by talking about unit testing, right? So what are these unit tests? So unit tests are tests that verify a very small piece of code, right? Or unit. And that unit could be a class or a method, something very small and completely isolated that we want to verify if it works properly or not. Right? And so the idea is that these tests are going to be running very, very quickly, and that is because they run in isolation. They're not going to be combined with the entire breadth of components of your system, but only that one specific piece, the unit, right? And so, like I said, they run in isolation, so you're not going to be involving the database, you're not going to be involving any external system or the file system or the network even, right? It's just that one class, that one unit that you want to be testing. And the focus of unit tests should be always on the domain, on the business rules, on the logic, the key part of the system that makes your system different from any other system. That's what you want to be unit testing, not the entire system. And so let's go ahead and take a look at this unit test in action. So I have my Matchmaker API over here. And the actual API, if we go into Program CS, you're going to see that we have, this is where the startup of the system, of course, and then we have this map matchmaker endpoints call over there. So we go over there is just an extension method that defines really by using the minimal APIs framework of ASP.NET Core, it defines that we're going to have one group of endpoints called matches over there. And in that group of endpoints, we're going to have both a post endpoint and a get endpoint over here, right? And the post endpoint is the one that we can use to just send a post using this join match request over here, where you can see it only receives just a player ID. So people can invoke this endpoint here by using the player ID, let's say player 1. And then we're going to have this component called the matcher, game matcher, that's going to be in charge of matching that player with any other player available, if available, or creating a match, and then just returning back this get match response, right? And so we also have another API over here, but we're going to be focusing in this one API here over there. So how do we test this one API? Now, the good thing about the way that this code is looking right now is that the actual business logic has been isolated into its own component. So, and that component is right here, the game matcher. So this is the only component that knows how to actually do the matching between players, right? And so that's a great practice, because otherwise, if you had all that code laid out right here in the post endpoint, then you would have this mix of concerns, and you would make everything just too hard to test. So if you go into get matcher over there, you're going to see that this is the one class that has this particular method here, match player async, that's going to take care of doing the whole logic of how do we match players. We're not going to go into the whole logic over there, but that's the logic that we want to unit test. So how do we unit test that? Well, let's go now into our unit test project over here, unit test. We have tests both for the entity, the game match entity, and then also for the service, the game matcher test. So let's go into that one over there. And you're going to see that this test class over here, what it does is that it has a bunch of unit tests to test that specific logic of matching, right? And so as a good practice, each of these tests are named in the right way, right? So we're saying what is that we're going to be testing. In this case, match player async, that's the unit. Then we're saying under what state we're testing, when in this case is when there's already a match for the player, 16 match for player. There is a match for this player, right? So what would happen in that case? Well, in that case, we should just return the match. That's the last part of the name of the test. Okay, and then we follow also a good practice here in terms of how do we lay out the different parts of the test. So in that case, we have first the arrange piece, which is where we prepare everything for the test, right? Then we have the act piece, where we actually run invoke the test on the subject of the test, in this case the game matcher. And then finally we have the assert part, which is where we say, okay, did we get the result that we expected to get, right? And the way that this particular test works is like, okay, so it defines a match, a game match, for in this case for player 1. And then one thing to notice here is that there's going to be a collaborator with the game matcher, right? So we go back into game matcher very quickly. So game matcher over there, we're going to see that it does collaborate with another component that's called the repository, right? The repository is the one that takes care of storing or retrieving data from our database. So, and that one is injected via dependency injection over here. But luckily, we don't inject the concrete instance of the repository, but just an interface. And because of that, back in our test over here, we can mock that. We can say, okay, I don't want to introduce an actual repository here because that would involve the database, and that's going to slow down the whole test. It's not what we want to do for unit testing. So we're going to say, okay, you know what? We're going to be creating this repository stub, and for this I'm using this library called mock, You see mock here. So it's just a mock of a repository. And we say, okay, so whenever anybody calls a find match for player async in the repository using this player one from the match, we're going to just go ahead and return this one match that we have prepared beforehand for the test. All right. And then we say that we expect to receive this game match response, which we're just crafting right here out of the match itself. So then we go ahead and create a subject under test, which is going to be our get matcher, using the object behind that stop, the repository stop, and also the object behind the logger. We just created a stop for the logger. And so then we go ahead and run the actual test over here. Here's where we run the test. I mean, we invoke the unit on the test, which is the match player async method, right? Using our join match request over there. And then we go ahead and assert that we're receiving the response or result matches what was expected, right? And so by the way, I'm using the Fluent assertions library here, which makes it this read very, very nicely, very naturally. So if we just go ahead and say run test over here, you're going to see that we should be getting a result in just a few seconds, because the very first time we run it, but usually it's also just milliseconds. So as you can see, it's just discovering the test, and we got a passing test right there. Right? So as you can see, unit tests run very fast. They run in isolation. It did not have to involve at all the endpoints. The endpoints are not involved. It's just that one unit over there. And if you wanted to run the entire suite of tests, we can also do it by using this extension I'm running over here. Here we can see all of the unit tests on the left side, and I can click over here, and that's going to go ahead and run all of the tests. And in just a few seconds, we should be able to tell if the core business logic of the application is in good shape. As you can see, that's all passing. So we know that both the entity and the actual game matcher service are working as expected. So that's great. But we did run all of this in isolation, right? So we would also want to have some other type of test that can test everything together, right? Even the database and all that stuff to make sure that things work across the entire breadth of components. So that's where integration tests come into place. So what are these integration tests? Well, integration tests are these ones that verify the interaction between different units or different components. It's not going to be just one class or one method. Now we're going to be combining multiple components of the application to see how they work together. And then the focus here is going to be really mostly on out-of-process dependencies, right? So it's not just about combining multiple classes together, but to involve components that actually are going to reach out to things that are outside of our process, right? So things like the database, things like a network call, things like a file system call. So things that are outside the system, which are the ones that are potentially going to cause trouble, right? So we want to make sure that our application is actually working properly together with those. And so this is going to give us a much higher confidence that the API is ready for deployment, right? Because now that we know that we can work with the database, now we know we can call the external system, now we have a much better confidence that things are going to be working properly, as opposed to just testing individual pieces. Of course, this is going to be more time consuming because we need to involve all these other dependencies, out of process dependencies, and it's going to be a little bit harder to diagnose failures, because if something fails, it's not going to be that we know that that exact method or class is failing. We have to figure out where exactly in the whole set of components things are failing, right? So a bit harder to diagnose, but still they have some good value in there. So let's see how these integration tests actually look in practice. So let's go back to Visual Studio Code, and I'm going to go ahead and just close all of this, and let me just switch into my integration branch over here, where I have a bunch of integration tests ready. So let me restore this, and let me just also do this over there. Okay, so let's just close that, and let's go now here. So remember that we do have our matchmaker endpoints over there, right? So we want to test that this endpoint actually works, the actual endpoint, not just the classes inside. So now we have this other project that I call integration tests, and we have this matches endpoints tests. So what's going on here? Well, if you see here in this new test class, we have this other component called the Matchmaker Web Application Factory. And this is a class that allows us to kind of simulate the actual web server, right, with the entire set of Ethernet core pipeline and all the dependencies plugged in to see if things are working together. If we take a quick sneak peek into that, we're going to see that, so this is a class that inherits from Web Application Factory, and then it does define its own database, right? It's not the real database, but a database made for the tests. And by the way, the application is using SQLite, so we define a SQLite connection, and we have the ability over here to do things like, let's just scrap the database and open up a brand new connection, which sets up a brand new connection. And then we have this method here that which is in charge of preparing our database context to be able to be used across these tests here, right? And so a super handy class, and because of we have that class, we have the ability to do things like this, right? So we create the application over here, And then we can prepare the request, the actual request that we're going to be sending into the API. We can create a client, right? This is going to be a client object, an HTTP client that is going to be talking to the API from the outside, right? And because we have that client, we can go ahead and send a request like this, right? Post async into our matches endpoint with the request. And then we can start doing things like verify that we have the proper response status code, and then that we have, an actual positive ID, the right player ID, and the correct state. Right? All of that can be enabled here. And if we go ahead and click on run test over here, we're going to see that just like with the unit test, it's kind of the same idea, but this is going to be a bit slower because it actually has to stand up an actual database, and it does have to talk to the ASP.NET Core application. As you can see, the test passed, it was all successful. And if we place a quick breakpoint, also we can see this in action. If I have a breakpoint over there actually already. So if we go back into the test, and if we put a breakpoint over here too, we can see that if we click on debug test, let's debug this test, we can confirm that we can actually dive into the actual API from the outside. So we exercise the entire ASP.NET Core pipeline to verify that all of that works. And as you can see, here we are, and let me collapse this and that. So here we are in the test. So we're going to call post as JSON async. And so now we just jumped into the actual endpoint, matchmaker endpoint. And if we do F11, we're going to go inside our game matcher. So another component. Let me just keep doing F1 like this, like that. And then if we go over here, we can do F11 and we can go inside the repository object over there, right? And we can even go like this is the actual query that's going to be used over there, right? So we are going across every single piece over here. And if I just click on hit continue, that's going to just do the other things. And then we are back into the ensure status code, and then that just succeeded, right? And so that's kind of the integration test that you can create here. And I think I have a couple of them over here. If I go back into my testing pane over there, let me just refresh this. We should be able to see the new test spinning up over there, and we can go ahead and run everything together. As you can see, we have the integration test right there. So I'm going to rerun everything. So as you can see, everything is running together now, and we should be able to now get a good picture of not just the unit test, but also the integration test. And it's all done. Right? So that's great. So now we know that our API is working properly from the point of view of the outside and going all the way into the database. But there's one more thing that we want to verify, and it's the typical end-to-end scenario, right? So let's go back into our slides over here, right? So now we'll talk about end-to-end tests, right? So what's about these end-to-end tests? So end-to-end tests, like I said, these are the ones that validate the system from the user's perspective, right? From if a user would use the system, what would happen? But the problem with this end-to-end test is that, of course, they're super time consuming because they have to exercise everything. If you have a UI, you have to go from the UI to the backend and then to the database. That just takes a long time. They are very fragile because many things could go wrong, right? The network could go wrong, the database could go wrong, the UI may have changes that we have not accounted for. So many things to maintain. It's just too hard to maintain. So very fragile, so very easy to break. And so if something fails, there's a million places where things could have gone wrong. So it's very hard to diagnose, right? It's also challenging to prepare the entire test environment and the data setup for this kind of test. And so there's kind of limited scenario coverage, right? So it's very hard to pinpoint or to test very specific corner cases of the application, right? So because of all of these problems, there's this new other kind of test that's called contract tests today. So what are these contract tests? Well, contract tests are also ones that can ensure that the contracts between different services can be honored, right? And so this is going to allow us to, allow making service changes without having to affect other services. We're going to be focusing really very strongly in the contract defined between different services, right? And so make sure that we don't break those contracts. So this is going to allow us to have early detection of integration issues. We don't need to stand up the entire system for testing. And this is going to promote also the communication between the different teams, because we have to agree very strongly in the contracts enforced between the different services. Okay, and so those contracts are going to also become the living documentation of the service interactions. Now, to do this kind of testing, there's this very nice tool called Pact, which has a variation for different languages. There's one for .NET. Let me bring up these actors here. So basically what you're going to be testing is a consumer and a provider, right? So you have the provider. In this case, let's say there's going to be another actor in our application. This is going to be the game manager. So the game manager is another service, let's say a microservice, is in charge of spinning up a game whenever matchmaker says, hey, I have a match ready. I have 2 players. Please provide me a game instance so that these players can play, right? So Game Manager is a service in charge of that. So that's the provider. So this provider is going to provide a contract that's going to say, hey, the game is ready. So whenever the game is ready, it needs to provide that message back into the consumer, which is going to be Matchmaker, to say that the match is ready. Here's the IP, here's the port where players can play, all that stuff. So in this case, the consumer, Matchmaker, when it has this contract, is going to create its own view of the contract from the point of view of the consumer. It creates its own view and it's going to share that view back into the provider, so that anytime the provider tries to make a change into the contract, it can verify that it is not breaking the consumer because it has the view of the consumer on that side. Okay, so it's a bit hard to explain just with slides. So let's take a quick look at the code to see how this actually works. So back here, I'm going to go ahead and again, I'm going to close all of this. Close all of that. So let me go back into my terminal and switch branches. So git checkout to me contract branch. Okay, so right there. So let's restore dependencies. And now let's go back and look at our Explorer. So you can see that now we have a few more folders over here, and that's because we have another service here, another microservice per se, which is going to be just a worker. This is a Game Manager worker, and we're not going to take a look at everything that it does, but the main thing really here is the match ready consumer. So in this version, whenever the Matchmaker has the two players ready, it sends a message into this Game Manager saying, hey, and that's via a queue, by the way, sends a message and say, hey, please provide me a game instance. So Game Manager has this class called the Match Ready Consumer, which is a class based on the Mass Transit framework, right? The Mass Transit framework over here, which allows us to very easily consume and publish messages across services. So we have this consume method over here where we receive the message, right? The message from the other service, and we say, okay, we'll go ahead and do the work. It's right here. This is the awesome work it's going to do. And then we prepare a message, in this case, game ready, which is a message sent back into the other service, right? In this case, we say, here's the match ID, here's the IP address, and here's the port. That's what we're going to be sending back into the other place. So over here, we go ahead and say, okay, so just go ahead and publish. So back in our service, back in Matchmaker API, we now have this consumer that is ready to consume this game ready message. So we go ahead and receive the message, and it will use that to assign the server to the match, right? So it will use, again, the game matcher to assign the server to the match using the match ID, the IP address, and the port. Now, the key thing about this is that, of course, normally we'll have to do an end-to-end test to verify that all of this works properly together. But we don't want to do that. We want to do contract testing here. So how do we do that? So what we want to make sure is that this contract here, this contract called Game Ready, and let me go there, this contract has to be enforced, because if anything changes in this contract here, then our Matchmaker API is not going to be able to process that message properly. It's going to break, and it's not going to be able to assign the server address and IP and all that into the game match. So how do we prevent that happens? So that's where pack testing can help us there. So let me close this and let's go into our new project that we have over here. It's called Contract Consumer Tests over here, which it looks like just like a unit test, but it has a very interesting use here. So here we're going to be using this tool called Pact, PactNet, which is a version 4.net actually. And so the idea is that we have this Pact Builder object. We're going to see how we're going to be using that. But basically, you define this Pact, right? The Pact says that we have both a consumer and a provider. The consumer is a Matchmaker service, and then we have the Game Manager service on the other side as the producer. So Game Manager is going to produce a message that Matchmaker is going to consume, right? So that they can interact. So we're going to be using this Pact Builder object with message interactions. So we want to capture the interactions between the messages. So down here, we're going to see that we have our kind of a unit test, but which is really a unit test. Just the purpose of this test is to generate what is going to be this view from that the consumer can use to verify the pact. So if we go here, we're going to say that we want to find just some random message for the purposes of this test. And we're going to say that, okay, so Pact build, so we expect to receive a game ready message. That's a message we're going to be dealing with. Given that a game ready message has been pushed into the queue, right? And that message should have this JSON content. So we have a match ID, an IP address, and a port, right? And we want to make sure that we verify not just the names, but also the types of these objects. So specifically, we want to make sure that we use the type of the match ID, which is going to be an int, the type of the IP address, and the type of the port, right? we're going to verify that the message should be equivalent to the message. When this message is the one that we receive here as the parameter, right, should be equivalent to the message we defined over there. I should have used another variable name there. But regardless, the idea of this is that with this, we can go ahead and as a consumer, right? The consumer, remember we are the matchmaker. We can produce the view that we have of this contract so that the producer can use to verify that we're not breaking it. So to do that, let's just go ahead and run this test. We run this test. And the idea is that this is going to produce a JSON file, a small JSON file that represents our view as a consumer of this contract, right? So that was just generated over here under packs over here. You can see it's right here. Here's the consumer, matchmaker is the consumer, and down here we see the provider is going to be game manager right there. And then we have the actual message, right? So the message contents for the test were these, and here's the description, and then here's the matching rules. So the body should have an IP address and match ID, and then it should have also a port, right? And we're going to be matching also the types, as you can see there. So the document here is the one that we, the consumer, the matchmaker, are going to share with the provider of the message to say, hey, this is a view that I have. So to share that, we're going to just right click over here. I'm going to copy this, and I prepared also another test project. It's called contract provider test over here for the worker, right? I'm going to paste that over there, paste that. So now the pack is in the hands of the provider. So the provider will go ahead and say, okay, so now I know what is the view of the contract that my consumer has. So there is a unit test over here that we're going to be using this thing called the verifier. Very similar to the builder, but this is the verifier, and this is the one that in another unit test we can use to verify the pact, right? So we have the path to the pact over here, right? So here's the JSON file with the pact, and we're going to be preparing another simulated message over there, right? That's okay. And then we are going to say, okay, so we're going to verify, being the provider is going to be the game manager, so these servers here, with provider messages, right? So we're going to be creating in what they call the scenario. We're going to see a scenario is the a game ready message comes in, and it's going to be a JSON type, and then it should have the content of the message we're providing, right? And so we're going to be combining this one message over here, this game ready message, we're comparing it with the file source, the JSON file that was created. I'm going to verify that things are working as expected. So to test this, we're going to just open up our terminal. Let me open up my terminal over here. Let me close this, and let me switch to Game Manager, Contract Provider Tests. So let me just do .NET test with the proper logo over there, and that will go ahead and verify that the contract that the provider has matches the view that the consumer has of that contract. So if we see all the way here, we go all the way up, we can see that this passed, right? It passed, and it is a bit proposed, but it's interesting to see that, yeah, we simulate a message with this metadata, with this body, and it was successful. But more interesting than that, look at this. We have the statement that says verifying a pack between matchmaker and game manager. A game ready message, given a game ready message, is pushed to the queue, generates a message which includes metadata that the content type is a JSON, and it has a matching body. So everything is matching here, which is what we were expecting. So that is great, but how is that really useful? What is our real use case on how is this going to help us? Well, look at this. So if we go back into our game ready contract here, so like I said, this is the contract. What happens if the provider, in this case game manager, changes something in here? So let's say we change the IP address into public IP address, right? So we're changing the contract. So I'll do that, and I'll have to also make a small change, I think, in our let me open this match ready consumer. There may be a small problem over here. So yeah, this is now public IP address, right? So that should do it. Okay, so now we have changed the contract. So what we want to do is to rerun the test that we had before, right? To see if we as the provider, by changing the contract, are we going to break the consumer? Are we going to break it? Since we already have the pact, right? The pact is right here in this JSON file. We should be able to confirm this right away. So let's do this. Let's go ahead and go back into the terminal right over here. And let's do again .NET test, and let's see what happens, right? So upgraded contract, testing the path, and see, test run has failed. Why did it fail? Well, if you go all the way up here, notice this. So the test has failed, right? Pack verification failed, right? We have some stack trace over there, and we see a similar simulation over there, but let's look at the output. The output is also looking very similar, but now we have this thing over here, the matching body. The body is not matching, so there's a problem with the body, and we can clearly see the failures here over here, like test cases, right? Verify the path between matchmaker and game maker, giving a game ready message, is pushed to the queue, blah blah blah. A game ready message has a matching body, and the actual map is missing the following keys: IP address. So IP address has changed, and this is going to break the consumers, right? So here it is what has changed, right? So here's the public IP address that we're sending now, and this is what we was expecting before. So there is one pack failure, and because of this, we were able to verify that even before deploying this, we have verified that we have not broken our client, and we didn't have to do the entire end-to-end testing. So that's why I think that this is incredibly useful to test a system that involves multiple services working together in an end-to-end fashion. So yeah, that's pretty much what I wanted to show you today. And just as a closing resources over here, I want to recommend you 3 things. The first thing is a book recommendation. This is Unit Testing Principles, Practices, and Patterns. Very nice book by Vladimir Korikov. I really like the way that he describes best practices and some anti-patterns on unit testing and in integration testing. So totally recommended book, just check it out. If you want to know more about pack testing and contract-based testing, you can look at this URL over here. That's going to give you all the details on how to use this pack testing with .NET. And also, I'm coming up with a brand new unit testing course, a digital course. You can take a look at this URL over here. It's still work in progress, but it is coming. And if you're interested, if you want to know whenever that course comes out, please check out that URL. You will be able to get a notification whenever that course is ready. So, well, yeah, that's it from me. Thanks a lot, and have fun coding.